about the distributive property. So we just explored the associative and the commutative properties. Associative means that we shift the parentheses. So that allows us to change sort of the orders of operations on what we do first. Instead of adding left to right, we can add right to left. And we can do that with multiplication as long as it's all addition, subtraction. And the commutative property tells us that we can mirror those. All right. Use the distributive property to evaluate expressions. Use the distributive property to simplify expressions. Good. John Burns approximately, I thought John Burns was his whole name. John was his first name. Burns was his last name. But instead, it's John burns approximately 420 calories per hour by surfing. The chart below shows the time he spent surfing in 1 week. To determine the total number of calories that he burned surfing that week, you can use the distributive property. The vocabulary we're going to use are like terms, very important, simplest form, and coefficient. We'll also do something which we maybe talked about, which is standard form. So when we evaluate the expressions, there are two methods you could use to calculate the number of calories John burned surfing. You could find the total time spent surfing and then multiply by the calories burned per hour, or you could find the number of calories burned each day and then add to find the total. So rate times total time. So 420 times he surfed 1 hour on Monday, half hour on Tuesday. No, he did not surf on Wednesday. He surfed 1 hour on Thursday, didn't surf on Friday, surfed 2 hours on Saturday, and 2.5 hours on Sunday. Those are some big waves, by the way. So we could multiply 420 times each day's hour. 420 times 1, 420 times a half, 420 times 1, 420 times 2, 420 times 2.5. That would be method 2. Or we have the ability to add up all of those hours, 1 plus a half plus 1 plus 2 plus 2.5, and then multiply 420 times that total amount of time that he surfed over the week. And we see that no matter whether you use method 1 or method 2, you're going to get 2,940 calories burned. And this is an example of the distributive property. We took this and we distributed it to each term inside the parenthesis. That's called the distributive property. And what it says is A times the quantity B plus C equals A times B plus A times C. We're distributing this A times into each of those terms. And how I liken it is if you come to my house and I'm giving out Snicker bars for Halloween, I'm going to distribute a Snicker bar to anybody that comes to my house, and that's the distributive property. So I always liken it in that manner. So if well, let's do this. Let's do this. This is good. We can do this. If I was really good, I'd already have this prepped up. But let's go on the roll and you get to Snicker bar. Yes. I don't want a lot of Snicker bars. I want one Snicker bar. Can I pull that picture? Yes, we can. Let's see if that goes. Snicker bar? Yes. Okay, and who are famous? I saw Justin Bieber this weekend. Oh, the Biebs. Look at him. Holy moly. I saw the Biebs this weekend. And let's say Biebs comes. And I also saw Kanye West. I don't know if this will be appropriate picture, but hopefully it will. There we go. There's Kanye. Oh, we'll do that. I saw Kanye and Justin Bieber this weekend. How crazy is that? All right. So if and this is the parenthesis. So if Kanye and Biebs come to my house and they are trick-or-treating, then what you get is you will distribute that. They will each get a Snicker bar. So you would get, copy, paste, you would get Biebs, copy, paste, you get Biebs with a Snicker bar, right, times, it's a times, plus, let's do another, you'd get Kanye with a Snicker bar, right? Doesn't that make sense? If they come to my house and I'm giving away Snicker bars, you're going to get that. So because Kanye and Biebs aren't the same, they're both singers, but they're not the same people, you couldn't combine these two. So this is the real example. So if you have Snicker times Biebs plus Kanye, you would distribute that and you get SB plus SK, right? Snicker bar times Biebs, Snicker bar times Kanye. And the reason why we would use the distributive property is because you can't add these two together. They're unlike terms. One are Biebs, one are Kanye's. And those aren't the same. So how do we simplify this? We simplify it by distributing out that multiplication. We can multiply unlike terms. We just can't add unlike terms. But in reality, you're going to see a problem like this. We can't add x and 4. One's a variable, one is a number or a constant. So we've got x-ray machines and we got $4. And we have this 5, so we can simplify this by distributing the 5 times to each of those terms. There are two terms. This is a binomial, two terms. Remember, terms are separated by addition and subtraction. And 5 times x, we can multiply unlike terms, and 5 times 4. Now we can't simplify these because that's 5 x-ray machines and that's $20. You can't combine x-ray machines and $20. So that's really where we're going to use the distributive property, is when we have something multiplying outside of a grouping symbol and the two terms inside the grouping symbol are unlike. If we had 5 times 3 plus 4, well, yes, of course, we're going to combine these two and make it easy. And we wouldn't use the distributive property in this case because we can combine the two things inside of the grouping symbols. It's only when you have unlike terms inside the grouping symbol would you choose to use the distributive property. So if you can still do the distributive property. 5 times 3 is 15, 5 times 4 is 20, and you still get 35. So that's an example of the distributive property. So a group of 7 adults, this is such a tricky question. Oh, when I did it first, I did it wrong. I got tricked. A group of 7 adults and 6 children are going to a University of South Florida Bulls baseball game. Use the distributive property to write and evaluate an expression for the total ticket cost. You need to find the cost of each ticket and then find the total cost. So I have 7 adults and 6 children. So typically you would think that you would multiply 7 times 7 adults times how much it costs for an adult. I would have thought 7 times 5 and then 6 times 3 because I have 6 kids and they are $3 a piece. However, groups of 10 or more, this is a tricky. Groups of 10 or more, I have 13 people. So in groups of 10, all the tickets cost $2. So I'm going to multiply 2 times 7 plus 6 because I have 7 adults, 6 kids, and I can distribute it, or I could have done 2. 7 plus 6 is 13, and I would have gotten $26. You can also use the distributive property, so that's why they would want me to distribute 2 times 7 plus 2 times 6, which gives me 14 plus 12, which is 26. So that works. You try. A group of 3 adults and 11-year-old and 2 children under 10 years old are going to a baseball game. Write and evaluate an expression to determine the cost of tickets for the group. I'm going to pause. When you're ready, unpause the video and we'll discuss the answer. Good. So we have 3 adults, and that would be $5 a piece. We have one 11-year-old and 2 children under 10. So that would be this one because it's 12 and under. So we've got a single 11-year-old and 2 under 10. So we would do that. Personally, I would add 1 plus 2. Maybe they want you to use the distributive property and you could distribute the 3 to the 1 and the 3 to the 2, but I'm going to simplify because those are like terms, and I would get 24. In this case, we're probably going to do this method because that's the most efficient. You can use the distributive property to make mental math easier. This one is actually pretty cool. So when you have 7 times 49, I don't know what 7 times 49 is. That is not one that is off the top of my head. But I do know that if I change this to 50 minus 1, because what's 50 minus 1? 49. And if I distribute 7 times 50 plus 7 times negative 1, notice where that negative stayed. That negative stayed with the 1, not the 7. What are we distributing? A positive 7, so this better be positive 7. We're distributing it to 50 and negative 1. So we better see the negative 1 there. I can multiply 7 times 50 mentally. That's 350. And I can multiply 7 times negative 1, which is negative 7. And I know that my answer would be 343. So the reason why they do this example is we can do that mental math. Instead of writing down 7 times 49, 49 times 7, 63, that's 28, plus 6, 28 plus 6 gives me 34. And so that was, but I can just do it mental math. So that's a kind of fun problem right there. Let's try. So when you see 304 times 15, what would you think to do? If you have 44 times 2.5, how can you do an addition or subtraction of something in order to get that? So we can do mental math opposed to having to do the hard written down. 210 times 5 and 52 times 17. So pause it when you're ready. Unpause it and we'll go through some answers. Lots of different answers. So I chose to break 15 into 10 and 5 because I can multiply 304 times 10 and then I'll distribute 304 to 5. So 304 times 10, that's easy. That's 3,040. Now I have 304 times 5. I don't know that off the top of my head. Actually, it's 1520, but I could do that in my head, but let's pretend we can't. So I'm going to break the 304 into 300 plus 4, and I'm going to distribute that to the 5 on each one. And I know what 300 times 5 is 1,500, and 4 times 5 is 20. So now I can add 3,040 plus 1,500 plus 20. So that's how I did it. You don't have to do it that way, but that is one of many ways that you can do it. 44 times 2.5, well, that's easy. I'm going to break the, I should probably do, oh no. I'm going to break, no, you're going to make that a pain. All right, I would do 2 plus 1/2, and then I distribute 44 to 2 and 44 to 1/2. 44 times 2 is 88. Half of 44 is 22, and 88 plus 22 gives me 110. So that's good. That one I can do. 210 times 5. So I'm going to break the 210 into 200 plus 10 times 5, and then I'm going to distribute. Notice we can backwards distribute. 200 times 5 plus 10 times 5, 200 times 5 is going to give me 1,000. 10 times 5 is 50, and that's an easier one. 52 times 17. This one's a little challenging. 52 times 20 minus, oh, Mr. Mac, what am I doing? Plus 52 times negative 3. Wow. And clearly I didn't finish this problem. That was bad. 52 times 20. Well, that's okay. I can do that. That's 1040. And then 52 times negative 3. I don't think I can do that. So I'm going to break 52 into 50 plus 2 times negative 3. So that's 1040. That's going to be 50 times negative 3 plus 2 times negative 3. I can do those. I got 1040. 50 times negative 3 is negative 1,500. 2 times negative 3 is negative 6. Oh, now we got 150 minus 1040. Oh, Mr. Mac's making it hard. Yep, okay, so if I subtract 100, right, of that 150, that gives me 940 minus 50 minus 6. If I minus 40 from the 50, you see what I'm doing there? If I minus 40, that gets me 100 minus 10 minus 6. If I minus 10 from 900, that gives me 890 minus 6, and that gives me 884. So hopefully those little tricks help you. See what I did? I subtracted 100 from that, and then I subtracted 40 because that, and then I subtracted the 10. So that's how my brain's working that. Simplify expressions. You can use algebra tiles to investigate how the distributive property relates to algebraic expressions. This is kind of interesting. The rectangle at the right has 3 x tiles and 6 1 tiles. The area of the rectangle is x plus 1 plus 1 plus x plus 1 plus 1 plus 1 plus x plus 1 plus 1, or 3x, there are 3 x's, plus 6. 3x plus 6. Therefore, we multiplied length times width. We would have had 3 times the length times the width, and then we would use the distributive property. Now we would use the distributive property because we can't add x plus 2. So we would have 3 times x plus 3 times 2, which 3 times x is 3x, 3 times 2 is 6, and we would get that. That one's okay. I don't mind that one. Rewrite each expression using the distributive property, then simplify. So I don't like this example. And I told you, what are we distributing? A positive 7. It doesn't show that we're distributing positive 7 here. We would be distributing a positive 7 to what two things? 3w and negative 5. So I want that negative there. Does it change the answer? No, but it makes a whole lot more sense when you look and see, what are you distributing? A positive 7. What are you distributing it to? 3w and negative 5. So I want to see those in my distribution line. What are we distributing in this next problem? We're distributing a 4. So I want to see a positive 4 being distributed to the 3 terms. What are the 3 terms? My first term is 6v squared. My second term is positive v. And then my third term is negative 3. Notice it worked this time because they put it on the backside. So we are going to multiply those. What is 6v squared times 4? We multiply the coefficients. 6 times 4 is 24. And then we have the v squared. We're going to multiply v times 4. Coefficient is 1. 4 times 1 is 4. And then we have the v. Negative 3 times positive 4 gives us negative 12. These cannot be combined because they are unlike terms. Unlike terms. Like terms have the same variable, to the same exponent. So, like terms, we can add like terms. We cannot add unlike terms. So like terms would be 3v plus 4v. Those are like terms. Same variable to the same exponent. That's v to the first. This is v to the first. So we're going to combine their coefficients when we add them. That gives me 7v. If we have negative 6ab plus 3ab, are they like terms? Do they have the same variables? AB, AB. Are the variables to the same exponent? That's a to the first, b to the first. This is a to the first, b to the first. So those are like terms. When we have like terms, we combine their coefficients. Negative 6 and positive 3 gives me negative 3. And then that's how many ABs we have. Here are unlike terms. Unlike terms are something like 3a plus 3b. Those are unlike terms. They do not have the same variable. So that's why we can't simplify those. That would be your simplification. This would be your answer. And then here's a fun one. When you have 2ab squared minus 3ab. These are unlike terms. They have the same variables. They both have ab. However, this is a to the first, this is a to the first, but this is b to the second. And this is b to the first. So those are unlike terms. We cannot combine their coefficients. We can multiply. You can multiply unlike terms. You can multiply and divide unlike terms. So if we have 3a times 4b, we're going to multiply their coefficients. 3 times 4 is 12. And we're going to multiply the variables, a, b. So we can multiply unlike terms. You cannot add and subtract unlike terms. Hope that helps. So let's try those. These are just distribution problems. Let's try these 4, distributing the number outside because it's multiplying into the terms. Unpause it when you're ready. So if we look at 3a, we have 2 that is multiplying the grouping symbols. We cannot add those two terms. They are unlike. One's a variable, one's a constant. So we're going to distribute the 2 to the 8. 2 times 8 plus 2 times 4n. 2 times 8 is 16. 2 times 4n gives me 8n. And then notice I did not leave this as 16 plus 8n. This is what I call standard form. The variable always has to come before the constant. This is what we call standard form. Okay? The constant always is going to come last. Let's look at, that's 3b. So we are distributing a negative 6 into the r, the 3g, and the negative t. So we're going to take the negative 6 times it by r, the negative 6 times the 3g, the negative 6 times the negative t. So you have negative 6 times r minus 6 times 3g minus 6 times negative t. Notice in each of these we have negative 6, negative 6, negative 6. And we're distributing it to r, 3g, and negative t. So 6r, negative 6 times r gives me negative 6r. Negative 6 times 3g gives me negative 18g. And negative 6 times negative t, two negatives multiplying make a positive, to positive 6t. Now, notice this is not in standard form. You have r, g, and t. So standard form is alphabetic order. if same variable, biggest exponent. Okay, so we're going to go alpha order, and constant will always be last. So when we go back here, we're going to go in alphabetical order. We have R, G, and T. What comes first? The G. So the negative 18G is going to come first, then the negative 6R, and then the positive T. G, R, T. Okay, so that is alphabetical order. Let's say we have 3a squared minus 5a to the fourth plus 4 minus 6a. We'll do that. How's that going to be? First of all, are there any like terms? No, there's no like terms. Yes, there are ones that have a's, but this is a to the second, this is a to the fourth, and that's a to the first. So there are no like terms. So this is simplified. We can't combine any of these terms. How many terms are there? There's 4 terms. 1, 2, 3, 4 terms. Okay, and so now if we want this to be my final answer, I have to put it in standard form. So alphabetical order, A is going to come before anything, and then it's the one with the biggest exponent. So I have negative 5a to the fourth plus 3a to the second minus 6a plus 4. So that is going to be your answer in standard form. Okay. Like terms are terms that contain the same variable with corresponding variables have the same power. And we just talked about that. So there are 3 terms, and none of these are like terms. There are no like terms. This is x to the second, this is x to the first, so those are unlike terms. And notice the constant came last. In the second example, notice we have a to the second and a to the second. So those are like terms, so we can combine their coefficients. This is a 6, that's a 1, so 6 plus 1 gives me 7a to the second plus 2a, and that would be my answer. We can't add the 7 and the 2 because they're not like terms. A to the second and a make them unlike terms. The distributive property and properties of equality can be used to show that 4k plus 8k equals 12k. In this expression, 4k and 8k are like terms, absolutely. We can, remember how you distribute the k? Well, you can also, what we call factor out the k, and that would have, if we take a k from both of these, that goes on the outside, and then you're left with 4 plus 8. And 4 plus 8 is 12, and you get 12k. I think it's just easier if you added 4k plus 8k. 4 kangaroos plus 8 kangaroos definitely gives you 12 kangaroos. An expression is in simplest form when it contains no like terms or parentheses. So we want to simplify those like terms. 17u plus 25u. If you have 17 ukuleles and then somebody gives you 25 more ukuleles, you would have 42 ukuleles. Here you have 16 times tables squared plus 3 times table minus 1 times table. These are like terms because they're same variable to the same exponent. This is not a like term, so we can't combine that. You're going to be left with 6t squared, and then if you have 3 times tables and you take 1 times table away, you're left with 2 times tables. Okay? How about you try these? Simplify each expression. If it's not possible, write that it's simplified. Pause it right now. When you're ready, unpause it. Okay, so we have like terms because they both have the same variable to the same exponent. So we're going to combine their coefficients. Coefficient is 6 and negative 4. So 6 and negative 4 make positive 2, and then you pull down the variable, 2n. Let's look at B. So you've got three terms here. You've got b squared, you got 13b, and 13. No like terms because you don't have the same variable with the same exponent, and you have no similar constants. So that is simplified. You cannot combine any of those three terms together. Let's look at 4c. Do we have like terms somewhere? Yeah. We got y to the first and y to the first. So I'm going to combine their coefficients. Positive 2, negative 8 makes negative 6y. And those other two terms are unlike. They're not constants. That's a constant, but we can only combine like terms. Y to the third is not a like term to y. And then the last one, let's look. We've got like terms. We've got a to the first there, 7a, and negative 2a. They have the same variable to the same power, so you're going to combine their coefficients. You have 7 and negative 2, which makes positive 5. And you bring down that variable. Now, oh, Mr. Mac made another boo-boo. Let's make that a little bit finer, because that should have a 2 over it, because that's a squared. Because I looked at it and I'm like, hold on, those are like terms, but they are not, because that should be a squared. And notice that I put it in standard form, a to the second, a to the first, and then that has no variable. So a to the second is going to come first, then a, then the constant. Write and simplify expressions. Use the expression twice the difference of 3x and y increased by 5 times the sum of x and 2y. So we have to write that twice the difference of 3x and y. So twice the difference of 3x and y increased, that's addition, increased by 5 times the sum of, that's the sum of x and 2y. So if we had to simplify that, we're going to distribute the 2 into both of those terms. You have 2 times 3x and positive 2 times negative y. And then we have 5 distributing out to the x and the 2y. And then we'd simplify 2 times 3x. They are unlike terms. However, we are multiplying, so we can multiply unlike terms. That's okay. So 2 times 3x gives me 6x. 2 times negative y is negative 2y. 5 times x gives me 5x. And 5 times 2y gives me 10y. Now, do we have any like terms? Yes, we do. We can add this x and this x. So we look at their coefficients, 6 and 5x. Oh, sorry. Notice that we commuted the negative 2y and the positive 5x. Notice that they switched. This switched and flip-flop because we wanted the x's next to each other. But because it's addition and subtraction across there, we know that we can flip it. It's only if everything, we can only use the commutative property if we have addition and subtraction across all of the terms. So 5x and 6x makes 11x. You see that? 11x. And then we have like terms with y's. So you have a negative 2y and a positive 10y. So we look at their coefficients. Negative 2, positive 10 gives me positive 8y. And we use the associative because we shifted the parentheses, and then we do the distributive property. Well, actually, that's not true. We actually add 6 plus 5. That wouldn't be the distributive property. That would be factoring. We factored out an x from both of those. So that's not really true. Use the expression 5 times the difference of q squared in r plus 8 times the sum of 3q and 2r. You have to write an algebraic expression and then simplify it for me. So when you're ready, unpause it. So translating it first, 5 times the difference. So we have 5 times the difference of q squared and r. Okay, so that's q squared minus the difference of r. And then plus, that's what that is, plus 8 times the sum of 3q and 2r. Good. So translating it looks like that. Then we want to simplify it. We can't combine those terms inside because they are unlike terms. Q squared and negative r are unlike. And then 3q and 2r are unlike. They're not the same variable to the same exponent. So how do we simplify? We can simplify by using the distributive property. We're going to distribute a 5 and we're going to distribute a positive 8 into those two binomials. Why did I call it a binomial? Because it's binomial because there are two terms. Bicycle 2. So we're going to distribute the 5 into both of those. 5 times q squared plus 5 times negative r plus 8 times 3q plus 8 times 2r. And we continue to see whatever is on the outside gets distributed to the two things on the inside. To the negative r, to the negative r. On the outside is a positive 8. We're going to distribute the positive 8 to the two things on the inside, 3q and 2r. And now we're going to multiply. We're going to always do multiplication. We have multiplication throughout this. Let's show that little. Right? We have multiplication, 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 and multiplication. And then we have addition, addition, and addition. So we're always going to multiply. 5 times q squared gives me 5q squared. 5 times negative r gives me negative 5r. Positive 8 times 3q gives me 24q. 8 times 3 is 24. 8 times 2r gives me 16r. 8 times 2 is 16. Now, do we have any like terms? Yeah, we have an r and an r. That's the only like terms. So we're going to combine their coefficients. Okay, these are not like terms. This q squared and this q are not like terms because that's q squared and that's q to the first. So we're going to combine negative 5 and positive 16 to get positive 11, and then we're going to put it in standard form. So q's come before r's, alphabetical order, and then q squared is going to come before q to the first. So our final answer is 5q squared plus 24q plus 11r. So the coefficient, we talked about coefficients. That's the number in front of a variable. So 6ab, the coefficient is 6. Oh, look at x squared over 3. The coefficient is 1/3 because what's the coefficient of x squared in the numerator? What's in front of x squared? A 1. There's an invisible 1 right there, so that's why it's 1/3. In the term y, the coefficient is 1, because 1 times y is 1. Good. All right, so concept summary, we know the commutative property. The two m's remind me of mirror. So a plus b is the same as b plus a. The associative, we're going to shift those parentheses. The parentheses start in the first two, and then we can shift them to the second two, because addition and subtraction, we can just shift those. Identity property is anything plus 0 will give me that value. A plus 0 equals a. And then the 0 property of multiplication is a times 0 equals 0. And the multiplicative identity is a times 1 equals a. Anything times 1 will give you the identity. Anything plus 0 gives me the identity. So that's important to understand. When we're multiplying and adding, 0 plus anything is going to give you that number. Anything times 1 will give that number. And then the last two are the distributive property and the substitution property. Good? Good. All right. There's the preparing for assessment. And the answers for that, here are homework problems and the answers to that, the additional problems. So please feel free to do those as if you want more practice outside of the worksheet that I give you. Woo, that was a long one. Good luck.